Okay, today is January 31st, and we're taking a look at radians and degrees, okay? So this can be a bit of a tricky topic. Now, when we take a look at a circle, we're used to looking at a circle and saying, well, that's 360 degrees, right? But this doesn't make a lot of sense. This is completely arbitrary. The reason it's 360 is because that's pretty close to how many days are in a year, so that's about how long they thought it took to travel around the sun. So again, completely arbitrary number. What would make more sense would be if we were to take a look at a circle and we were to consider its radius. Right, so this is one radius. And we might say, how many of these could we fit going all the way around a circle, right? So if we take a look here and we were to start, right, and this same length lied around the circle, right, we could fit 1, 2, 3, right? And a little bit more to get halfway around the circle. 4, 5, 6, and a little bit more. Okay? What this actually works out to be, so we've got here 1, 2, 3, 4, 5, 6, plus a little extra. What we actually come to find out is it's exactly 2 pi radians to go around a circle, or 2 pi radiuses to travel around a circle. And this makes sense because we know from our previous classes that circumference is equal to 2 pi r, or 2 pi times the radius. And this is true of any circle. So instead of measuring in degrees, what we're going to look at today is measuring in radians and figuring out how many degrees is equal to radians and how many radians are equal to degrees. Okay? So today we're just focused on basic conversion factors. All right? So we're going to start with this idea of going from degrees to radians. Okay. Now, if we want to go from degrees to radians, all right, I'm going to go ahead and take a look at problem number 2 on today's assignment, because you guys only have to do the evens. Okay, so I'm just going to show you number 2 and number 4, and then you'll do the rest of the evens. So here, we've got 345 degrees. All right. Now, I want to convert this from degrees to radians. Just like in science class, right, we can set up a conversion factor, and we always do with what we want over what we have. So we want radians, we have degrees. Okay? Now, if we think about this, a full circle, 360 degrees, is equal to 2 pi radians. If I divide each side by 2, I get my conversion factor, which is at 180 degrees, is equal to pi radians. So there's my conversion factor right there. I know that pi radians is 180 degrees. Now the degrees are going to cancel, and I'll multiply across. I get 345 pi over 180. Now I'm going to have to go ahead, I'm going to have to reduce this fraction. I might start with the number 5 and say, all right, let's divide both of these by 5. 5 goes into 345. It looks to be about 69 times. And 5 goes into 180, 36 times. So I get 69 pi over 36. I might say, hey, those are both divisible by 3. Divide them both by 3. I get 23 pi over 12. And then that cannot be reduced, so that is my answer. 23 pi over 12. All right. Number 4 on your assignment says negative 510 degrees. All right. I'm going to do want over need. I want pi radians over 180 degrees. I'm going to multiply. I get negative 510 pi over 180. I'll divide them both by 10. I get 51 over 18. I'll divide both of those by 3. 3 goes into 51 17 times. 3 goes into 18 6 times. So I get negative 17 pi over 6 radians. Alright? Now moving down the assignment, problem number 22, we now want to go from radians to degrees. So now we're going to go radians to degrees. So this is number 22. Okay. Here I'm given negative 25 pi over 12, right? And we're going to follow our conversion method, right? So So remember, this is radians, and I want degrees. So I'm going to do this time degrees over radians. And I know that 180 degrees is equal to pi radians. Now I just go ahead and multiply across. Now watch what happens here. Pi cancels with pi, and I'm left with 25 times 180 divided by 12. Alright. 180 divided by 12 is 15. So this becomes 25 times 15, which is going to equal 375 degrees. Don't lose track of your negative sign like I did. So I get negative 375 degrees. Alright. I can take a look. Number 24. I've got 41 pi over 36. Right? And again, I have radians, I want degrees, right? So what I want is 180 degrees over pi radians. Pi cancels with pi. 180 divided by 36 is 5. 5 times 41 is 205 degrees. Okay? So you can see not too bad. Alright? Your job is to do just the evens on that assignment. I know it seems long, but I did 4 of them with you, and there's 30 total, and it's just conversions. Alright? Go ahead and knock those out and submit your answers to Canvas. Thank you.